All right, folks, let's take a look at our 802.11 standards. If you've purchased an access point or a network interface card for wireless over the last 15 years, you've purchased one or more of these standards. These are the standards that have been implemented widely to support wireless local area networking. So we've got our A and B standards way back from 1999. 2003 ratified the G standard, and things got more exciting. 2009, we moved to the 802.11n standard, and then all the way in 2013, we have a ratified 802.11ac standard. So just good to know the order. Good news, they go in alphabetical order, so life is good. Frequency band. Notice 802.11b supports 2.4 gigahertz, as does G, and as does N. That's important to remember because common frequencies make available the possibility of backwards compatibility. Let me say that again. Common frequencies denote the possibility of backwards compatibility. We're going to see more of that, but that's really important to remember. So, as we look at that, again, what's at 2.4 versus what's at 5? So 802.11a, all the way back in 1999, we were using the 5 gigahertz bandwidth range. And 802.11n and AC continue to use that higher frequency range. Channels, and by this we mean the number of unique non-overlapping channels. With 802.11b at the 2.4 gigahertz, you have 1, 6, and 11 that are available according to the FCC in the United States, and that's what this is focusing on here, so 3 channels. G in the same frequency range also supports 3. But then when we look at 802.11a, it supports as many as 24. And remember, the bandwidth ranges are different. When we work at the 5 gigahertz range, the structure of the channels, the individual channels that are chosen, are different. They have the 64 subchannels. They're in 20 megahertz blocks, so they look and feel completely different than the channels used at the 2.4 gigahertz. So there are as many as 24 here. But when you go to N and AC, you'll notice it varies. Remember, that's because 802.11n and AC are going to support wider channels. Instead of just 20 megahertz, they can support 40 or maybe even 80 or 160 megahertz channels. So the number of channels that are free to select varies. Transmission type. Okay, so how do we encode the data? Direct sequence spread spectrum was the old method used by 802.11b. And 802.11g can operate using that, but it, as well as everything else, prefers to use the much more powerful OFDM, orthogonal frequency division multiplexing. Okay, multiplexing is a better methodology than spread spectrum. Okay, so again, that's the methodology used by all of those. Also has a relationship to backwards compatibility. Data rates. All right, our data rates that are available. So we're going to see different data rates are available by different standards. And this is talking about in megabits per second. So what we usually are most concerned with is the maximum data rate that's possible. So 11 with 802.11b, 54 with 802.11a. G supports 54 as well at the lower frequency. 802.11n supports up to 450 megabits per second, so a huge jump there. And 802.11ac supports potentially gigabit speeds, right? 1300 megabits per second with enough antenna and configurations. And the second wave, there's actually multiple waves of the 802.11ac protocol that are designed to be released. And notice how fast this is designed to go, nearly 7 megabits per second. So, I'm sorry, gigabits per second, so very fast. If I was trying to retain the information in this table before taking an exam, I would definitely, for my own sake of understanding, I'd specifically want to remember the association of the different protocols with the frequency, their transmission, and especially the maximum data rate that's available.